So today we're covering section 15 and making sense of statistics, which is on scattergrams. Let's do a quick review. Remember, correlation refers to the extent to which two variables are related across a group of participants. We talked about the concept of correlation in section 12, and then we also talked about the Pearson R in section 13 and the coefficient of determination, or R squared, which is used to interpret values of the Pearson R, which is described in section 14. And remember, the Pearson R is a statistic that concisely describes the degree of correlation between two variables, using a single numerical value to describe it. So let's now talk about a scattergram, also known as a scatter diagram. It is a statistical figure or drawing that illustrates the correlation between the two variables. This is rarely shown in research articles, but while they are seldom presented in research reports, by studying scattergrams in this section, you will. So let's look at example 1. Now, the scores in example 1 show scores on a basic math test taken before students enrolled in an algebra class, and also the algebra grade the students subsequently earned within the algebra class. So I've also given you a way to look at the GPA, where a 4 point is equal to an A, a 3.5 is an A minus, and so on. So that's on the right side of your screen. Well, what I want you to know is that Joey has a lowest score in math and the lowest algebra grade. Now, remember earlier, we've talked about a direct or a positive relationship. So since he has the lowest math score and the lowest algebra grade, we would see that this is clearly a direct or positive relationship. Now we see that June has the next lowest math score and the next lowest algebra. Let's also go back and talk about positive relationships. Remember, if you have a score on variable 1 that's low and you have a score on variable 2, or the algebra grades that's low, those correlate at the positive or direct relationship. So now when we look at this, the relationship between math score and the algebra grade is perfect. So we have an R of 1.00, which is a perfect relationship. And we also would say an R squared is also a 1.00. Now remember, if you square 1.00, 1.00 times 1.00 equals 1.00. Now a lot of people forget that, so that's something that we need to remember. Now, we talked about in section 14 that the values of R squared can be converted to percentages by multiplying the R squared by 100. So in this, we would multiply 1.00 by 100. We would get a 100 and a 100%. So here is what we can say for the following, for the previous example. We can say that 100% of the variance in the algebra grades is accounted for by the variance in the math scores. So the data in example 1 indicate the basic math scores are a perfect predictor of subsequent algebra grades. Now, if we look at figure 15.1, we can see the perfect direct relationship. We see the percent explained variance. And this shows the scattergram for the scores in example 1. So each dot, each of the red dots that you see, represent 2 scores for one student. So example, the dot for Justin shows that he had a score of 8 on the math test and his algebra grade of a 2.0 or grade of C in the algebra class. So because the relationship is perfect, the dots follow a single straight line. In addition, because the relationship is direct or positive, the dots go from the lower left corner to the upper right corner. Now, positive relationships are rarely found in social and behavioral sciences. So, for example, in practice, the relationship between math scores and subsequent algebra grades is far from perfect because different students have different areas of weakness, such as someone being really strong in basic math and weak in comprehending algebraic abstractions. So here again, let's reiterate, when a relationship is perfect, the dots follow a single straight line from the lower left to the upper right. Now let's look at example 2. Now this is the same as example 1, except Mike's math score and algebra grade have been added. So while Mike is near the bottom in math, with a 5, he is about in the middle of the group in algebra grade. As it turns out, the data in example 2, the R is 0.83. You can see that at the bottom of figure 15.2, which indicates the relationship is strong. It applies to all students except Mike, but it is not perfect because of Mike. Now, you can see that the scattergram is for the relationship between the scores in example 2. The overall trend clearly shows the relationship is direct. However, Mike's 2 scores are the exception. Here again, we have an exception, which creates a dot that is offline created by the other dots. So because of Mike's scores, the value of R has moved from a perfect R value to now from a perfect 1.002 now only a 0.83. Now remember the 1.00 in example 1 did not include Mike. Now also this gives us an R squared of 0.69, which means that we have 69% explained variance. So again, remember, perfect relationships are seldom found in the social and behavioral sciences. I cannot stress that enough for those of you who are in the social and behavioral sciences. Now let's also let's look at example 3. So here we have more exceptions to the trend. Now we've added Martin, Mitch, Mary, Mitchell, and Manny. Each of these deviates somewhat from the overall trend that indicates a direct relationship. So here we have these that were added. Now here is the scattergram, which shows the relationship between the scores in example 3. So let's also notice the overall trend still shows that the relationship is direct. The dots generally follow a pattern from the lower left to the upper right, but there are some dots that just indicate deviations from the trend. So now, because of all of this scatter that we see, we only see an R of 0.64 instead of the 1.00 in the example 1 and the 0.83 in example 2. So we have an R of 0.64, which is the R squared of 0.41, which gives us a 41% explained variance. So in everyday terms, example 3 indicates that the math test is 41% better than 0 in the ability to predict algebra grades. Also, that means that 59% of the variance in algebra grade is totally unpredicted by the math scores. Now we can look at example 4. Now, sometimes relationships are inverse, and we've been looking at positive and direct. So now let's talk about inverse. So on this example, there are scores on the variables of cheerfulness and depression. So you have a cheerfulness score and a depression score. So cheerfulness is measured with statements such as, most mornings when I wake up, I feel cheerful. And depression is measured with statements such as, I often feel blue on my way to work. Now, the participants responded to statements on a scale from strongly agree to strongly disagree. We summed their responses across the items so they could earn scores ranging from 0 or strongly disagree on all items to 30, marking strongly agree on all items on each of the variables. So examination of the scores suggests an inverse or a negative relationship. So let's look at this from our scattergram. So here again, we see a negative or an inverse relationship. Now, one of the things is that we could have looked at Blair and Leslie having high cheerfulness scores, but they have the lowest depression scores, and Hilda and Oscar have the lowest cheerfulness scores, but they have the highest depression scores. So those who are high on cheerfulness tend to be low on depression, and those who are low on cheerfulness tend to be high on depression. So if we look at the overall trend, it does show that the relationship is inverse. There is, however, a scattering of dots that indicates the relationship is not perfect. And in an inverse relationship, the dots generally follow a pattern from the upper left to the lower right. So when we look at the R value of this particular figure, 15.4, we see the R value of negative 0.79. So the corresponding value of R squared for an R of negative 0.79 is 0.62 for 62% explained variance. Now remember, if you multiply a negative times a negative, you get a positive. Okay, so remember that. Put in everyday terms, the data indicate that the cheerfulness scores are 62% better than 0 in the ability to predict depression scores, and 38% of the variance in depression scores is unpredicted by cheerfulness score. So here are some things to take away on this. So these are some of our concluding comments. When the dots form a pattern that goes from the lower left to the upper right, the relationship is direct or positive. When the dots form a pattern that goes from the upper left to the lower right, the relationship is inverse or negative. When the dots perfectly follow a single straight line, the relationship is perfect. And the greater amount of scatter around the line, the weaker the relationship. So for example, in this would be a low positive correlation. This would be a low negative correlation. This would indicate no correlation.